Hello everyone. This is the third video I'm making for the Test 3 workbook. This will cover the anynormal versus normalxbar tabs on the worksheet. So for this, I'm going to be using example problem 60. So we have potato chip weight centered around 10 ounces. And the amount is believed to have a normal model, mean 10.2, standard deviation 0.12. And so what they're saying is that the potato chip company can guarantee 10 ounces because they're filling bags with a mean of 10.2, standard deviation of 0.12. Interestingly enough, the practice of overfilling food, especially the implementation of the baker's dozen, was actually one of the kings, Edward. I can't remember which one. Might have been Edward III. But they actually regulated the weight of bread in England. And because bread dries out when it sits out at the market, bakers could get like in serious trouble, like really, really debilitating fines by letting their bread dry out in the market. So they started over baking. And if it was late enough in the day, they would even throw in an extra loaf, right? And that's how we get the baker's dozen as an extra loaf, because at one point you could go to jail if your breads were too low or you're too light. All right, so anyway, that's why we're here today, doing statistics about potato chip bags. I hope that was interesting to everyone. So how do we do the first part? What fraction of the bags are sold underweight? Yeah, this is the part where people don't go to jail for underfilling anymore. What fraction of the bags are sold underweight? Notice this is not about a sample. This is about the population. It's a darn good thing they told us the population was normal. And that's why we can use the anynormal part here. So what's our mean? 10.2, just type that in. What's our standard deviation, otherwise known as sigma? That's 0.12. Hit and enter. What do I want to know? When are the bags underweight? Okay, so I'm going to use the y less than value version. Again, we've got less than, between, and greater than. Y less than, and I want it to be less than 10 ounces. Anything less than that is an underweight bag. Oh crap, I'm done. Oh, there you go. That's that. Yep. We typed the numbers into the form, and the form gave us the answer. Yes, that's how it goes. Okay, so hey, some chips are sold in bargain packs of 3 bags. What's the probability that none of the 3 is underweight? Geez, I mean, you could do that with like a card counting probability argument. You know, right? There's a 4% chance each bag is underweight. What's the chance that we get? What's the chance that we get 0.9953 times 0.953 times 0.953, right? Do it that way. Let's move on to part C. Part C is more interesting. What's the probability that the mean weight of the 3 bags is below the stated amount? This is where we need normalxbar. This is why I wanted to do this problem. So our sample size is tiny, it's 3. Our population standard deviation is 0.12. Our mean is 10.2. And so, yep, we've thrown in our sample size, we've thrown in our population standard deviation and our mean, and it spat out our sample standard deviation. All right. Now, what's the chance that the mean weight is below the stated amount? Stated amount is 10 ounces. It says so right here. Okay, so I'm going to use y below again, or y less than, not between, not greater than, and I'm going to test for less than 10. And there it is, fellas. So the lower standard deviation, the crimping the standard deviation by taking a sample, has actually, well, geez, I mean, it would be unlikely, since there's only a 4% chance that one bag is underweight, it's unlikely that enough bags would be enough underweight to pull the mean below 10, right? Yeah, okay. So, well, let's finish it off here. D. So, what's the only thing that changed between C and D? We're not talking about 3 bags. We're talking about 24 bags now. So really, if this comes up on a test, this is what I want to see. Change 3 to 24, hit enter, and what do you note? It's ridiculously unlikely. Write a dot, write 15 zeros, then write a 1, 6. What's the probability that, yep. And so what do we see there? We see that the sample size is continuing to cut down our standard deviation, meaning that our means will be more tightly clustered around the population mean, which means that it's even less likely to get a sample mean of less than 10. Think about that. The 5 standard deviations to get 0.1, right? So more than 5 standard deviations below is what that is. All right, I hope that was helpful. So yeah, so we built it up, right? We started with a normally distributed population, did some calculations about the population. Then they threw a sample size at us. So we switched over to normalxbar, sample size, population, standard deviation, population mean, a little bit of normal probability calculator here. And that's how it does it, guys. As we use more of the workbook skills, getting into chapter 18, I will post a few more videos about this. Hopefully, we'll get at least a tutorial for each one of these. And I'll see you guys at noon or 1, depending.